Hello, this is my project 3.3.2 CHUMP EEPROM. In this stage, I programmed two EEPROM chips to permanently store the machine's language version of Feinberg's sample Japanese code. These chips act as the CHUMP's memory system, holding the program that the processor will later execute. The EEPROM, or electrically erasable program read-only memory chip, is different from RAM because it keeps data even after power is removed. Each EEPROM has an address line, data lines, and control pins. The address lines, A0 to A3, choose which memory cell to access, and the data lines, I0 to 6, carry the binary values that represent hexadecimal digits on this dual segment display. The control pins, write enable and output enable, tell the chip when to write and when to output stored data, which is how the EEPROM was burned. To load the program, I use an Arduino Nano as a burner. The microcontroller sets the address, drives the correct byte onto the data pins, and sends a short low pulse on write enable to write that byte permanently. Each write operation uses this function from my sketch. The pulse sequence writes one byte at a time to each of the 16 addresses. I created two separate lookup tables, Feinberg left and Feinberg right. Since the wiring for the left and rights is slightly different, the left EEPROM displays 8126D, while the right EEPROM shows 20120. Once both EEPROMs were programmed, I switched the microcontroller into read mode. The data pins were set to inputs, and the output enable line was pulled low to enable output. Now when I cycle through the addresses 0 to 15, the display shows stored program bytes in order. This visually confirms that each instruction was written correctly and matches the Japanese program table. In the actual CHUMP computer, these EEPROMs are connected to 4-bit program counter outputs from the SN74L S161 chip. Each time the clock advances, the counter changes the address line, and the EEPROM instantly outputs the corresponding instruction byte. This stored program approach replaces the complex logic wiring with the digital memory, just like a real CPU. The program's EEPROM holds instruction data, while the second control EEPROM will later store timing signals that coordinate the processor's modules. Thank you for watching my demonstration on the CHUMP EEPROM stage. Make sure to follow along for the next part of this build. See you guys soon.